Let's look at experimental design in organizational psychology. We're going to especially look at one exceptionally powerful design called the pre-test, post-test control group. Now, when we talk about experimental design, there's all kinds of factors that we need to consider when designing an experiment. The one thing that all experiments have in common are random assignment into two groups so that we can measure if the average between the two groups is significantly different. But when we actually design it, there's a lot of choices that we need to make. Let's suppose that we want to measure we want to test the effectiveness of some training programs at, at work in some organization. So one factor that we have to consider when designing an experiment is the dependent variable, the outcome variable, the criteria variable. How are we going to measure how good the training is? There's a lot of ways of doing that. We could give a test. We could look at profits. We could ask the subordinates. If it's a leadership training test, we could ask people's subordinates how good of a leader they are. There's lots and lots of different dependent variables that we could use to measure the effectiveness of training. So that's one factor to consider. A second factor is the independent variable or variables to manipulate. So we want to study the effectiveness of training. Well, how are we going to, the training is going to be the independent variable. How are we going to manipulate it? What levels of training are we going to use? We could have a control group where people receive no training, or if there's a traditional training that's going on, we could have a group that receives the traditional training, and then maybe there's a new and improved training program. That could be the experimental group. We could compare one of the control groups to the experimental group. Or maybe we could look at the new improved training and have a one-day seminar or spread out over 6 weeks. There's all kinds of ways that we can manipulate the independent variable, so we have to choose the one that interests us. So that's choosing the independent variable to manipulate, and then how we're actually going to do it is how long it's going to be, what one are we going to choose. And then finally, the fourth thing is how are we going to measure the dependent variable? How are we going, if we choose that, let's use supervised or subordinate ratings of the employees, well, how are we going to do that? We need to have some type of tool, maybe some type of survey that will accurately measure the leadership skills of the supervisors who went through the training, or which would capture the changes that the training was supposed to make in their behavior. So these are all kinds of complex things to consider when we design an experiment. Now let's look at a couple examples with this experimental training. Let's look at one design known as a post-test only control group. Now what we have in this illustration is this going from left to right is like a timeline. This is where we start. This is where we finish over at this side. So we start off with random assignment of participants into a control group and an experimental group. So if we had 100 employees, maybe 50 would go into the control group and 50 in the experimental group. And as far as we know, they're identical, these two groups, because they're completely random and any differences are just going to be by chance, which means most of the random error is going to cancel out. And then each group's going to receive what's known as the treatment, and that's represented by X's in this type of notation. X sub C that the control group receives is the traditional training. The experimental group receives X sub T, which is the new and improved training. So both groups are going to receive training, and that's the only thing different between the groups other than the differences that existed by chance when we started. Now then, over here, we have the the post-test. We call it a post-test because we measure something before or after post the treatment. So the post-test one is, well, there's only one post-test in this model. It'll be the leadership rating by subordinates 6 months after their training. So the subordinates would be surveyed 6 months after to evaluate the bosses, the supervisors that went through the control group training, the traditional training, and also the subordinates of the 50 who went through the new and improved training would be surveyed too. And what we would do is we would get an average value for the post-test of the control group and the average value of the post-test for the experimental group. We would do a t-test to see if they're significantly different. And if they are, we can say that one training was better than the other. Now, if we were only interested in finding out if the experimental training was better, we could make a one-tailed test. But if we wanted to see if either of them were better than the other, we'd have to make a two-tailed test. So that's what we would do to test. Once we have the post-tests for both groups, we would compare the average scores for each group. So this is a post-test only control group. It's a fairly easy, we only have to do 2 measures, but it has some weaknesses too. There's going to be some differences between the groups by chance. So that means the differences in the outcomes need to be pretty big. It's got to be bigger than the differences between groups. And so if we're expecting the training to do a lot, which generally we shouldn't do because so much training is not very effective. But we do expect the training to do a lot, then we could do a post-test only. But sometimes we might not expect the training to do a whole lot. It might not be any different. It might not make that much of a difference, and the difference between 2 groups might kind of cover up the difference that the training occurred. In this case, we would use a more powerful experimental design. And this is called the pre-test, post-test control group, where we start off with a random assignment of participants into a control group and an experimental group, but we give each group a pre-test. O1 here, we measure the outcome. So this would be the pre-test measurement, the leadership ratings by subordinates, maybe 1 month before the training. We might not want to do it right before the training because supervisors might be thinking, oh, training is coming, I better be on my best behavior. But if we did it a month before, we'd get their normal behavior. And so we measured for both the control group and the experimental group beforehand. And it will be it won't be that big of a difference because it's pretty much what we would expect by chance. Then we give the control treatment, which is the traditional training, and the experimental treatment, the new and improved training. And then we make a second observation of the outcomes. So leadership rating by subordinates, maybe 6 months after, to see if they made some real changes. Now this has the advantage is that we can look at each participant's before score and after score of their subordinates. So somebody who said, oh, my supervisor was a 6 here, maybe he's a 6.5 here, and we can look at the difference, and we can check the average of the differences rather than just the averages. And that's important because maybe this one, they rated their boss as 6.5 and they rated their boss as 6.0, and the difference was just due to chance. And on the post-test, this might come out to 6.5, and this might come out to 6.5. Now, if we didn't have the pre-test, we'd say, aha, 6.5, 6.5, not significantly different. But if we know, aha, this went up 0.5 of a point, this one didn't go up at all. It went from 6.5 to 6.5. It was a 0 change compared to a 0.5 change there. That's a more powerful way of detecting differences, and we have a greater likelihood of doing a significant t-test to see that there's been a change in scores that way. So this experimental design, the pre-test, post-test control group, is a very powerful way of finding out if some treatment makes a difference in some group.